Welcome back to the series. And in this video, we are going to cover the queries, the QS queries, which actually a library that Strapi suggests us to use so that data collection via the API, it makes it much more readable. And that's what we have been using in our queries in the previous videos. And now we're going to see how these things work. All right, so let's go to the backend and analyze the data a little bit. So what we have here is restaurant, and these are the basic data that comes with it. And then we can add all the components, menu item, photos, etc. These things become extra added baggage to our REST API. On top of that, we can have locations. Here, one-to-many relationship between location, restaurant, and cuisines, many-to-many relationship, etc. And when we go back to cuisine, we also see that it has the same relationship with restaurant, vice versa. And that being said, let's go look how data is collected from the backend using the API endpoint. And here you see this API endpoint /API/restaurants. And this is where the data we're getting is the base data, no additional stuff, right? And then we improve upon it. Let's say we want to get all the attached baggage, and all we do is add restaurant $populate equals asterisk. And that gives us the photos, the menu items, the locations, and then cuisines, reviews, etc. All the extra baggage now came. Now, not always we're going to need all the information, right? We're going to need to filter them. Sometimes we may need just a photo, or sometimes location and cuisine, but not reviews, etc. So let's check it out how we're going to do this. So let's say we don't want any extra baggage, but just the photos, right? So if we add it like this, /populate equals photos, that's when we get this one extra item only, photos, right? Which normally we wouldn't have gotten. So now let's add to that. Let's come up with, let's say, location and photos, and then we run it, and we get photos and location. Just like this, we can keep adding stuff to it, and now things get really, really complicated when we're going to need information from inside location, some added stuff. For example, let's go back to the data. And here, let's say location now. We're getting just the location information, but we also want to add restaurants that comes in the same package. So in here, if we want to try to get inside location and add stuff to it, the query will become really, really complicated and ugly looking. But that is not impossible, right? And that's when the QS query comes in to help us out. And in my Next.js front end has a API endpoint, because Next.js is a full stack framework. So right there, I have created something like this. I created one API endpoint, QS-Strapi. And that's where I write my code using the QS library. I add filters, etc., and get results like this straight from the Strapi backend via the Next.js API. So this is where we're gonna spend, rest of our time on this video. I'm gonna keep changing the queries and see the results right here. So let's get to it. All right, so we're back at the code. And as you can see now, it's under pages, under API. I have created this URL endpoint, QS/Strapi. It has all the necessary stuff. I've imported the QS library here. And I have created an utility function, which is under /utils. So just to go take a look at it, just so that we have a proper setup right here. So here, QS to Strapi. Basically, what I'm doing is I am collecting the Strapi API key so that I can make the calls directly from my front end. And here I am providing that API key as a bearer for authorization in the header. And I'm going to pass my base URL as I set up right here, and I'm going to send my endpoint as a string here, and this is what we're going to be using to make the call to Strapi. Result will be given here as a JSON response data. We're returning await response.json. So this is the function we're calling here to take care of the necessary stuff to make the call to the backend. And now we have a clear picture of what we're doing here. Pretty much we're calling this function here, with a async await. And right here we are sending our URL endpoint as a string and attaching our query, the query which we will create that QS library using the QS.stringify method. So now that what you see here, we're going to have it very simple one, just a query which will have populate equals asterisk, and that's what we're going to be using now. So let's go check out what data we get. All right, so we have our endpoint setup /API/QS Strapi, and let's run it. Oh, there you go. We're getting all the necessary data right here. So now let's start changing and altering and manipulating that QS library-based query so that we can see how we can build our own custom queries in a human-readable format. All right, so we are back at the query, and this time we made the query a little bit different because this time we are specifically asking to add location, cuisine, and photos. And out of all the other fields, we are specifically asking for name and description only, nothing else, right? So now let's go back and rerun it. Oh, there you go. So now we're getting nothing but name and description and location, cuisine, and photo. Every piece of data would consist of just exactly what we asked for. Okay, so let's analyze our data a little bit, the restaurant data. So let's go in the first one and see we have certain things here like price. Price could be regular, cheap, or expensive. And this one is set to regular. Also, let's see, it has a location like this, cuisine, and some other relation stuff. Oh, for example, here is featured. It could be true or false. That way it becomes a featured item. Let's see, check out this one. See, this one's set to expensive. And also this one is a featured one because is featured set to true, has online ordering true, and location Alfreda, etc., etc. So now that we know a little bit more detail of our data, so now let's go back to our query and come back to add some filters to it. Okay, so now we are back to the QS query again, and this time we are limiting them to name and price. Our query will return the restaurant's name and price only, and it will filter by the price that are set to our data item. For example, could be expensive, cheap, or normal. So here we choose expensive. So let's see how that works. Let's run this. All right, look at that. All of them came nothing but expensive. All right, we're back to the query again, and this time we are sticking to the name and price, and we are asking for the expensive ones, but this time we want to add the location and cuisine, but we're filtering even further, and inside location we don't want any other information, just the name, and inside cuisine we just want just the name, keeping it simple. So let's see what we get. Running it, and that's it. So we got the name, we got the price, and we got the location name only, and the cuisine type just the name. All right, so I'm gonna go ahead and analyze our data a little bit. And here, let's pick this one. Let's check this ID number 3, and let's go in. And here we see a whole bunch of reviews are involved. So let's get some extra data, and also let's look at the review, and the review would have the star ratings, right? Some 4, 3, 5, etc. So based on that, let's try to get some specific data on a specific restaurant. Okay, so here, look at our query this time. We're asking for the name and price, and we're filtering by ID, the ID EQ. I mean, these are the things that, this is one of the qualifiers that Strapi gives us to compare data. And here we're going to use populate and bring in location name, cuisine name, and reviews. And we will only display the content and star ratings. And here we're going even deeper. Inside those reviews, we're going to populate the user information, basically try to find out who actually left the reviews, find out the username and email. So let's go back, and we're gonna run it. And there you have it. You have the name, the price is regular, location, name is Alpharetta, type is fast food, and it is actually showing us the reviews with content and star rating. And the user data is coming up now because I think the users are not connected. So let me go attach them and come back. All right, so I went ahead and attached usernames to the comments. So now let's run it again. And this time, besides the comment content, the user information attached to it. There's another user. There's another user. Let's move to the next step. Okay, so we are going to get some location information, and we're going to be specific about it. Let's pick Atlanta, ID number 1. So let's go to the query, and here we're introducing one new layer in our filtering system, which is sorting. So we're going to take the names and sort them in an ascending order, and we're going to show name and price field, and location equal to ID equals 1, which is Atlanta, and then we're going to populate the location field with just by the name. Let's go run it. And look at that. We only get Atlanta information, all Atlanta, ID number 1, and have nothing but name and price. In total, we got 7 items. All right, this time we're going to go ahead and sort them in a descending order, the name item, and then we're going to bring in name and price field. But this time we're going to have a little bit more complex filter. We're going to enter 2 different things. We're going to filter by price, which has to be regular, and location ID is 1, which is basically Atlanta. All right, so now let's go back and see the results. Run it. And there you go. Check out the order, UTCB. So it's in a reverse, like a descending order, sort, and then price is regular, and all of them should be from Atlanta. Let me add something that actually shows Atlanta, and I'll be right back. Okay, so I altered the query a little bit, kept everything the same, just added, I'm populating it with the location and asking for only the field name. Rerun. There you go. Getting only the Atlanta location, price regular, and only the names. Next step. Okay, I should have been showing you this earlier, but now that we're moving into a little bit more complex queries, so I wanted to show you the operators that Strapi let us use. We're familiar with this one, $EQ equal, and then we have not equal, less than, equal, etc., etc. And we also have and, or, and not. So these are the ones we can use as an operator within our query to do some advanced filtering. So this time we are sorting in an ascending order, and then the fields we're asking for is name, price, is featured, and has online ordering. These are actually booleans. That means true or false. And then this time we're filtering with an AND operator, and putting in two conditions in there, both of them has to be true, which means the result we're asking for, it has to be featured item. At the same time, they have to have online ordering enabled, right? And the location we're looking for is Atlanta, which has an ID of 1. And just so that we can see the name, I'm just populating with the location and only the name field, right? So let's run this. Right, look at that. We got only one answer back because we had an AND operator. So that means in the whole database, we have only one item that is a featured item, and at the same time, it has online ordering enabled. And let's go to the next step. All right, so let's check out a different collection this time, reviews. So here we have content text, stars with a number, and we have two relationships with the one-to-many, with the restaurant versus reviews, and another one-to-many with the restaurant versus user. So let's dig into this, get some data from here. Okay, so right here we changed to reviews instead of restaurants, and here we are sorting the results in an ascending order, but instead of name, we're going to choose ID. And the only field we're asking for from here is the stars, that like 3, 4, 5, whatever number. And then we're going to filter it with a user ID, which is 12. And let's see who that is. Let's go to our data and let's go find number 12. Number 12 is Batman. Okay, so in here we are getting the restaurant and the username. We're basically populating them with. So this is the full query, and let's go see what we get. Running it, we got the email address and we got the restaurant name, and we found only one data. Now let's move on to the next. All right, so this time we're gonna try to do a search, like a full text search kind of deal. So basically we are still targeting the reviews collection, and we're going to be focusing on the content. And in here, we're using the OR operator. So we're going to be looking for this one, this text, NIHAD or NIMAD. But look at that they are of different case, right? One is in uppercase and one is in lowercase. So that's why we are using this operator, contains I. So if we use normal contains, that will just look for these words, but it's going to be very specific as far as case goes. But if I add this I in front of it, it's going to go ahead and bring up wherever it finds these two words, one or the other, and regardless of what case they are in, right? This query would be a very good one to learn how a full text search is performed in Strapi. So let's go run it. All right, so we got about 4 total searches, but if we look at the content now, we see NIMAT here, but which used to be we were actually searching for lowercase one, and NIHAD here, NIMAT here. So regardless of case, it went ahead and found the content that actually holds these words. All right, so this is going to be the last one and the biggest one. You have to watch carefully what happens here. So we're going to target the reviews collection, right? Which has only content and stars. The rest are just relationships. Okay, one-to-many, and user is one-to-many. So what we're targeting here is we're going to query this reviews field, but we're going to dig deeper into its relationship field, and we're going to get even deeper inside this restaurant relationship data. So basically, there could be things like items inside restaurant. For example, we go here, okay, and we go here and we see that inside restaurant we have reviews, and then in the review, we have a user attached to that review, right? So it's pretty much 3-level deep. So that's what we're going after this time. We're going to target the reviews, but we're going to go inside the restaurant collection that is a relationship, not a data point, a relationship. And then we're going to go inside that, get photos, location, and cuisine, and then go another level deeper. Inside the review, we collect the user. So let's see what happens. All right, let's run it. Boom, there you go. So we have our review content and star rating. Then we dig into restaurant, and within that, we find photos, locations, cuisines, review, and then within the review, we go one level deeper and find the user data that is attached to that review, and this review, which is attached to this restaurant. So we went at least 3 levels deep, and we got our data back successfully. And with that, I finished this video. Thanks for watching.